Okay, guys, here we go. Today is your last day of Chapter 5. Everyone do a happy dance. We're going to be modeling with polynomial functions today. And so everything we do will be on the calculator, which is why the notes will be short and you'll have an in-class assignment to do because you'll need the calculator to do it. So for the first two examples on your notes, it says to use finite differences to determine the degree of the polynomial function that fits the data. So to start with that, we have to use what's called finite differences. And finite differences is a fancy way of figuring out the difference between each of the y values. And y'all have done this before with quadratics. We're just taking it one step farther with cubic. And so from 1 to 4, I go plus 3. And the signs are important because you'll just see that later. The signs are important. So include a positive or a negative if you're adding or subtracting. 4 to 10 plus 6, 10 to 20 plus 10, 20 to 35 plus 15, 35 to 56 plus 21. Now, those numbers aren't all the same number. It's not changing at a constant rate. So because it's the first time we counted, it's not linear. So we count again. From 3 to 6 plus 3, 6 to 10 plus 4, 10 to 15 plus 5, 15 to 21 plus 6. So for finite differences, it didn't work for the first row. The second row, we still have numbers that are not the same number, so it's not a second degree function. So we're going to go one more. From 3 to 4 plus 1, 4 to 5 plus 1, 5 to 6 plus 1. Because we had to count the differences 3 times, 3, we call that a third degree function. 3 changes equals third degree. This is helpful for us because when we go to use our calculator in the stat edit function to find the equation for this polynomial, it tells us which method we need to choose to calculate. So what you want to go ahead and do now is go to stat edit, and you're going to type your x's in L1 and your y's in L2. If it was a quadratic, we would have gone stat over to calc, and we would have chosen quadreg. If it was a linear, we would have chosen linreg, and I'll give you guys 3 guesses to figure out what we're going to use this time since it's a cubic function. Hopefully you guessed number 6, cubic regression. So stat, calc, 6. And there's your equation. Now what does all of this mean? F of x equals 0.166666667. I don't want you to write that as a decimal. I want you to write that as a fraction. 0.1666667, where the repeating 6 is 1/6. And if you didn't know how that was 1/6, I will show you in a minute how to find that in the calculator. But 1/6 x cubed plus 1/2 x squared plus 1/3 x, and then for the coefficient or the constant, it gives you a really small number in scientific notation. If you think back to when we were graphing and trying to find intersections, and I told you when you got a number that was a really small scientific notation, that just means 0. So I'm not even going to write it because it's just 0. So to recap what we did in number 1, we counted the finite differences 3 times, so we knew therefore it was a third degree function. We put this entire table in stat edit. We went to stat calc 6, cubic regression, because we're talking about cubic functions, and we got this function that represents these data points. Now, let's say you didn't know that 0.1666667 was 1/6. Well, go back to your home screen, and I'm going to type in that decimal. And this might seem like overkill, but you want to make sure that the entire top row is filled with the same repeating decimal. Your calculator only recognizes it as a repeating decimal when it happens like more than 9 times. So to be safe, just fill up the entire row. Then you're going to choose math. Number 1 says frac, short for fraction. And lo and behold, 1/6. So again, repeating decimal, you have to fill in the entire row with the number that's repeating before you tell it to find the fraction. So at this point, I would tell you to pause the video and try number 2 on your own, and then come back and check your work, but I'm just going to move right into it. To figure out the changes here, from 6 to 15 plus 9, 15 to 22 plus 7, 22 to 21 minus 1, 21 to 6 minus 15, 6 to negative 29 minus 35. This is why this example is a good explanation of why the positives and minuses are important. Because now as I go through and count these finite differences, because obviously for the first row those were not all the same number, I'm counting from 9 to 7, which is minus 2. I'm counting the difference to get from 7 all the way to negative 1, which is minus 8. The difference from negative 1 to negative 15, which is minus 14. And then negative 15 to negative 35, you have to subtract 20. I don't get the same number in my second row, so I keep going. Negative 2 to negative 8, have to subtract 6. From negative 8 to get to negative 14, subtract 6. Negative 14 to negative 20, subtract 6. Lo and behold, our third change is all the same, which means it is also a third degree function. So, go back to your calculator, stat edit. If you go up to the name in the calculator and highlight it and press clear and then enter, it will clear out the entire row for you. Don't press delete. Delete will get you, it will delete the entire column, just clear. Type your X's in L1, your Y's in L2. And again, we're going to go stat, calc, 6. Here we got lucky, we had no decimals to convert, so we write our function, f of x equals negative x cubed minus 7x squared minus 7x plus 21.